Hello, dear colleagues and attendees. Today I want to present you work on the topic synthesis of neural networks models for technical diagnostics. Hello, dear attendees and colleagues. Today I want to present you work on the topic synthesis of neural network models for technical diagnostics of nonlinear systems. So, as the main thesis of the work, we must notice that nowadays machine learning models, for example, neural networks, are very often used for the such tasks as diagnostics tasks, which can be represented as multi-class classification tasks. And for example, we use neural networks as a models in these tasks, but we have a very big question how we can synthesize models with a high level of accuracy. So this was a main goal of our work. As a problem statement, we must say that we must do synthesis the new neural network with a high level of accuracy, because in this task we talk about a high level of security, what is more life security of the people. So, but when we talk about such difficult task, what's the level of complexity of this task? In our work, we present a list of some indicators which can help to choose the level of complexity and so on in the future, choose the strategies which can be used for bringing new solution in this complexity task. In our work, we choose a random complexity because we have not maybe such something like a big data, but something near the big data. What is more, we talk about the high level of accuracy of final solution because as we noticed, we talk about the security of people's lives. So we choose a random complexity, and as you can see in the slide, as the future strategies, it using some modern topologies and architectures of the networks in combined with some fine-tuning methods, for example, reinforcement learning methods. And let's talk about it. We choose the GRU model. It is something like complicity recurrent neural networks, but instead of, for example, long short-term memory, it not using some difficult memory cells, but it use some number of gates which can help to notice the previous state of systems and using it to forecasting the tuning of the system in the future. So it can help to make more and more accuracy forecasting or more and more accuracy classification. What is more, we use actor-critical method for training this model. Actor-critic method, it is one of the swarm intelligence methods or a method which or some method which work in reinforcement learning approaches. As you can see, we have two big agencies in this method. One agent is the critic and the second it is the actor, and the main task of the method is to make actor do some stages and some strategies so good so critic can make the huge policies on it. The dataset for our experiment are well known for all of us, but I must notice some points in this slide. For example, we use special Python libraries, TensorFlow agents for reinforcement learning methods, and Keras for different artificial neural networks models as deep neural networks, recurrent neural networks, and so on. We talk about this in the next slides. So in this slide, you can see the main test results. We talk about synthesis time and accuracy on different part of the dataset. It was the training part of dataset and the test part of dataset. And yes, as you can see, we use even the usual perceptron with combination of back propagation, but as you can see, it's one of the most fast solution in this slide, but the accuracy are not so good. This is some which can demonstrate that even simple artificial neural networks architectures can be used in such tasks, but the accuracy of this solution are not so good. And something like a conclusion about these experiments. As you can see on the slide with experiments, the accuracy of different neural networks are not so different, and it's more than 90%, but combination of the GRU and actual critical method demonstrate one of the most best accuracy, but it must take the large number of time to synthesize the optimal solution. Deep neural networks work even more faster, but as you can notice, the most combination use some method which can be represent as a parallel method and can use parallel computer systems. That is why they are very high iteration, and even they can use a parallel system, so the time of it are like something that fixed. When we talk about the reinforcement learning and the actual of critic, we can talk about the using of parallel system and represent it as a parallel method. So it can be less iterative, but it will use a parallel course and work more faster in the future. It is one of the future prospects of the work. And as you can see, we use different approaches to this task, but the accuracy of the solution find must be the most. So in this work, we present the combination of GRU and actual critical method, and in the future, this approach can be reduce more and more accuracy and more faster, but in the future work. In this, that is all about our work in this stage, and I'm thank you for your attention.